All right. So I guess we'll just start with question number 3.
Yeah, go ahead.
Question number 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z 1.358 and to the left of z negative 1.358. So you just use the applet, type in 1.358. I got 0.175.
Yep, that's what I got too.
Is that what you got? Okay.
Yep.
Yeah, awesome. I'll read question 4.
All right, which of the following will have smaller standard deviation if 9 observations are randomly drawn from a population? I got whatever B or whatever the distribution of the sample means.
Yeah, I did too.
And that was because of, let's see. I don't remember why I got that.
It's because the standard deviation of a sample is the standard deviation of the population divided by the square root of the sample number.
Oh. Yeah.
Yeah,
okay.
So because it's divided by that sample, the square root of the sample number, it would be smaller than the individual observations.
That's right. Okay, cool.
Question 5. Which of the following results implies that the spread in X bar decreases as the sample size increases? I said the law of large numbers.
Yeah, I got that as well.
Yeah. Because the
Makes
spread
sense.
can be determined as the standard deviation, and according to the law of large numbers, the standard deviation decreases as the sample size increases.
Yep. All right, so using the following information for the next 4 questions. So Diane earned a score of 160 on the quantitative portion of the GRE, which is what is the Z-score corresponding to Diane's score. That was just the normal Z-score formula. And I got 1.045.
I rounded to 1.046 just because I think it was 1.04. It was like 0. I can't remember. I don't know. That might be wrong. I might get that wrong.
Let me see. So
I had
160 minus 150.8, and then divided by 8.8. So it's 1.045454545.
Right.
So it should just be 1.045.
Okay.
I don't know if you want to do the calculations again yourself, but
yeah, I just figured because I think like when you're rounding down, at least in Excel, I think it rounds up. Yeah, let me see real quick.
Well, I don't know, when you're rounding 3 decimal places, you only round the third. You
just round to the 4th one.
Yeah.
Right. Okay. I'll do that. Question 7. What is the probability that a randomly selected student... Sorry, what was that?
I didn't say anything. Go ahead.
Okay. That a randomly selected student will score above 160 on the quantitative portion of the GRE. So the probability, you just use that Z-score, plug it into the applet, and it should give you 0.148.
Yep, that's what I got. Okay, so question 8. I struggled on this one a little bit. I couldn't remember.
Yeah.
But you put the numbers in and you get the mean, right?
Uh-huh.
And it's 160.
Mm-hmm.
And then, let's see, how did I do that? And then you take, what was it? Was it 5? I can't remember.
So we're trying to find the z-score of this sample.
Isn't that the one you have to take the square root of the sample size?
Yeah. So you'd have to find the standard deviation of the sample size. So you do that by taking the standard deviation, which is 8.8, divided by the square root of 5, because there's only 5 students.
Okay, so the answer I got is 2.467.
I got 2.338.
Okay. What's left?
Because I took 160 minus 150.8, and that gives you 9.2. And then you divide that by 8.8 divided by the square root of 5.
Let's see what I get on that one.
Mine might be off because I don't have a scientific calculator. So I'm just doing the individual calculations and then just taking them out several decimal points.
Let's see here. Let's all listen up. Let's see, square root of 5. I don't know. What did you get? You got,
I got
2.338. 2.338.
Mm-hmm. So I just typed it in again, and I got the same answer. So
okay, we'll go with that one.
Okay.
Because we have both the same idea. The problem is like the square root of 5 is like,
it's
what is it, like 2.236? You know, like
23606. I went out 5 decimal.
Okay. Maybe I just didn't go out enough decimals or something. I don't know. We'll see.
Yeah. Question 9.
All right.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? And we're rounding to 4 decimals. So this, to find the probability, we just plug in that z-score, 2.338, and we take the area to the right, which I got 0.0097.
Well, if I type in your number, other than the one I got.
Right.
But we're going to go with that one. So if we have to go back, we'll go back.
Okay. Can we go with question 10?
All right. All right. Suppose the GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. The distribution is left skewed. A random sample of 81 students will be drawn. So what is the shape of the sampling distribution variable, which represents the sample mean of the 81 students that are selected? Let's see. I think it's approximately normal.
Yeah.
Because of the large sample size.
Mm-hmm.
Okay, cool.
Yep. Question 11. What is the mean of the distribution of the sample means, the sampling distribution for all possible samples of size 81 that can be drawn from the parent population? So I had to go back to the reading, but it said that basically that's the X bar, the mean of all possible samples, and it equals the mean of the parent population. So it's 3.5.
Yeah, that's what I got too.
Okay.
Okay, so 12, right? So 12. What is the standard deviation of the distribution of the sample means for all possible sample sizes? Sample of the size 81 that can be drawn from the parent population. So that was the one you take the square root and divide, or the square root of
81.
Yeah, 81. And then divide what?
So you divide the standard deviation, which was 0.7, divided by the square root of 81, which is 9.
I got 0.008.
I got 0.078.
What the heck? Where did I get? All right, let me see that again.
0.7 divided by 9.
Okay, so
did you do 0.07? That might be.
Maybe.
Yeah. The standard deviation is 0.7.
Oh, maybe I did 0.7. Hey, Addie, what? Sorry.
That's all right. We're almost done.
What was the answer that you got?
0.078.
That's right. Okay.
Another 0 in there for that original standard deviation. Question 13. What is the probability that the mean GPA for 81 randomly selected Boole Idaho students will be less than 3.3? So for that, we're going to do 3.3 minus 3.5 divided by that standard deviation that we just got for the sample. And I got and then that will be our z-score. We'll plug that into the applet to get the probability of what's to the left of that negative z-score, which was, I think it was, I got negative 2.564 was the negative z-score that I got from
2.564, yeah, that's what I got.
Okay, and then to the left of that is a probability of 0.005. Is that what you got?
Did you say 0.005?
Uh-huh.
Yeah.
Okay. And
all right. So what is the
question? The opposite. Right?
Yeah. What'd you get on
that?
So
just be 1 minus 0.005, which would be 0.995.
Yeah.
And then you want to read 15?
Right. Sure. So United States Coast Guard assumes that the mean weight of passengers in commercial boats is 185. The previous value was lower, but was raised after a tragic boating accident. The standard deviations of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. So we're finding the probability that a random sample of passengers will have a weight that is extreme or more extreme than was observed in this sample. All right, I did not get this one.
I actually didn't either. So I think we got to find the z-score because we're trying to find a probability.
Okay.
I just wasn't sure which value we're using. So we know that the mean is 185. So
what does it mean that they changed the weights? I mean, I don't understand. Like,
I think that was just a comment saying that it used to be less than 185.
Oh.
But because there was a tragic boating accident, they had to bump it up to 185. I don't think that statement really, or that sentence really
Just trying
adds
to
value.
kind of try to throw you off.
Yeah.
Right.
So the standard deviation is 26.7. The mean is 185. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6. So we're trying to find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. So I think we use 177.6 pounds as our sample mean. So in that case, it would be 177.6 minus the mean of 185, which is negative 7.4.
Negative 7.4.
Divided by the standard deviation, which is 26.7, over the square root of 48. So that's how many passengers there were. So that is square root of 48 is 6.928203. So 26.7 divided by that number is 3.85381. And then, what did I say? Negative 7.4. The z-score would be negative 1.920.
So the z-score, and then
Then it wants to know what's the probability that it will be.
So one.
I think.
So we're doing the probability. Let's see. What's the probability that it'll be as extreme or more extreme? So would that be like the probability of above the mean and just right at the mean, or you know what I mean?
Yeah.
Would it be both together? I mean, like, I don't know.
Probability that random sample of passengers will have a weight So I'm pretty sure that that sample mean of 177.6 is what we're supposed to use to get the z-score. And then, so if we were to do just the area to the left of z-score negative 9.20, that would tell us what the probability of the random sample being...
I think to the right of it would be extreme, and then to the far right would be more extreme, right? If the z-score is negative, right?
But in that parentheses, that's what gets me, is it says either above or below the mean.
So maybe just do the 2. I don't know, because that's what, 97%? Is that what you got?
Shoot. When you say the 2, you're talking about like
just the above the
in the applet?
Yeah.
Trying to conceptualize. So if we have a z-score of 0.1920 for the sample of 177.6 pounds, basically that's stating that that it's 0.05, well, 0.0274 probability that
it's above the, that would be extreme, right?
That it's below the,
I mean, yeah,
the mean. Probability. Oh wait, here's a note. As extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also that are as far away from the mean as ours in the positive direction. Oh, I think that means it wants both to the left and to the right.
Okay. So that'd be the
0.0549. So we're doing the smaller triangles to the left of the mean and to the right of it.
To the right of the mean.
That makes
0.0549.
Yeah.
Well, let's give it a try.
0.549.
Where did you find that extreme?
So that,
it's in that note. I didn't read that note.
Yeah, I didn't either.
Okay.
0.549. Okay, let's see.
So it'd be 0.055.
Oh, yes. Huh, almost.
All right. Well, let's see what happens.
All right.
Hey.
Turns out we knew what we were talking about.
Think you knew what you were talking about?
I don't know. That was definitely a brain teaser there.
Yeah, it was. All right, man. Cool.
Cool. Any questions?
No, I don't think so. No.
All right. I'll get this posted.
All right, buddy. Thanks, man. You have a good night.
See ya.